Thanks for joining us for our Brown Bag webinar. Today's presentation is a very quick introduction to cryptocurrencies, blockchains, and smart contracts. If you haven't already, please put your name and your school in the chat box so that we have a good record of attendance. There should also be time at the end for Q&A, so if any questions or comments come up during the presentation, please put those in the chat box as well. There also will be a very short 6-question survey for everyone at the end of this half hour. So our presenter today is Dr. Debasis Bhattacharya. He is currently a tenured faculty member at the University of Hawaii Maui College and program coordinator for the Applied Business and Information Technology Baccalaureate program. Dr. Bhattacharya has been working in the software and higher education industry for 32 years, having worked for large corporations such as Oracle and Microsoft for 15 years. A resident of Hawaii since 2002, he has been actively researching the information security needs of small businesses since 2008. As a former small business owner himself, he understands well the needs and demands of information security, as well as keeping a small business up and running. Dr. Bhattacharya holds degrees from MIT, Columbia University, University of Phoenix, and Northwest California University School of Law. He's also a senior member of the IEEE and the ACM, and a member of the Academy of Management. Debasis taught a summer work connections track for us actually a couple of years ago on this very same topic, so we're very happy to welcome back to this webinar. So we thank him for your time, and I'll turn it over to him now.
Okay, again, my name is Debasis Bhattacharya. I've been with UH Maui College for more than a decade. Seems like a long time. I put a couple of students' names there because, as you all know, students are very helpful in setting up presentations. And the last time I was in Colin College, they actually did a lot of work in setting up the lab. So even though they're not students anymore, I put their name just to remember. Everything in this presentation was supported greatly, not partially, by the NSF award. So anything you have here, you can reuse at will. You don't have to credit me. Just make sure the code works. Okay, so I'm going to go through this pretty fast. I'm going to skip some of the slides. I was thinking of cutting down the number of slides, but then I thought Rajiv would object because he wants to know everything. So I put in more slides than less slides. So just take it for what it is. This is just about the basics of the underlying technology. This is not about making you rich by buying and speculating in Bitcoins. That's a whole different lecture, and it's not my expertise. Bitcoin is a cryptocurrency that is traded across the world. And every time I do this presentation, I do the slides the night before the presentation, largely because there's some action that happens 24 hours between my making the slides and the presentation. The last time I did this in May, the Chinese government did something and the Bitcoin price crashed overnight between my slide making and the presentation. So this is the state of Bitcoin as of today. So if you type BTC or Bitcoin, you'll see this. It's for the past year, it's wildly speculative and volatile. Okay, but this is just about prices. I'll get into what it is and what Bitcoin actually is in a moment. But this is from a very high level. Price is what we pay for it, right? Rajiv pays 41,000, I pay 40,000, somebody else pays 45,000, et cetera, et cetera. But since it's a cryptocurrency, what is happening is it's based on transactions. So if you look at the slide, you'll see a couple of statistics. You'll see things like hash rate, transactions, transaction volume, et cetera. And we'll get into this a little bit, but this is like the dashboard of the Bitcoin system. Okay. And I've put links at the bottom of my slides. So after this presentation, if you want, you can click these links at any time. So let me go through the initial slides first. Bitcoin at a very fundamental level is a series of blocks. Think of a block as a folder, and it's linked to the previous block. Okay. A block has transactions in it. And what's a transaction? A transaction is let's say something between me and you. I pay you a Bitcoin for something, and that's a transaction. And so a block is a folder or a list, however you want to think about it, that contains many crypto transactions. And if you look on the left side, you will see something called height and something called mine. Height is the length of blocks from the very beginning. So when I created this presentation, there were 7,001, 701,601 blocks from the beginning, from the first block. Okay. And we'll get into what mining is in a minute, but each block was created in about 5 minutes. That's this number. So these are the number of blocks in Bitcoin at the time I created the presentation. And these are the people who actually solved the problem. And these are the transactions that are going on right now when I was creating the slide. So these are some concepts in Bitcoin that we're going to get hopefully familiar with at the end of the session. But these are just, at this point, you may not quite understand what these things are. But let's go back a little bit in time. The first Bitcoin was coined by an unknown person who goes by the name Satoshi Nakamoto on 8th of January 2009. Okay, and if you look through this thing, it is there's a certain number of Bitcoins, there's a certain size, there's a 50 Bitcoin, 50 BTC was the first transaction. Okay, and all you have to do to find this block is to go into blockchain.com, go to the link below and type one for being the first block. Now, the reason I have this slide here is because it shows that 701,601 blocks have been created since the first block. Okay, and this is the first block by Satoshi Nakamoto. So Bitcoin from 2009 to about 2014 was just a cryptocurrency. It was just a system that kept on running. You couldn't do anything about it. You could just buy and sell Bitcoin, right? So it got pretty boring. People made alternatives, they forked the code, they did other stuff with it, but it was just a system of buying and selling cryptocurrency. And what happened in about 2014 and 15 is we had Ethereum, which was a copy or a clone of Bitcoin system, but allowed users to write programs with it. Okay, so this programmability was a big deal because what you could do is you could write little code that you could put on the blockchain that you could execute. And so Ethereum essentially led to what is known as smart contracts. And we'll actually see a little smart contract today in about 10 minutes later. It's simply a program usually written in languages that remind you of C, which essentially does some execution all on the blockchain. Okay, and a common programming language is called Solidity, and we'll get into Solidity a little bit later on. I've got a couple of labs on it. So what smart contracts did was allowed you to write some code that did something. So this spawned a whole series of programs that basically had fungible tokens. And what that means is that it led to images being stored on blockchains. And now you have videos, you have all sorts of stuff on it. But it was because of the fact that you could write a smart contract that led to the system doing a lot more than just trading cryptocurrency. Okay. So this was a big deal in around 2015 and still is. Now, Ethereum also has a cryptocurrency. It's called Ether. And as you can see, this is the prices of Ether for the last 7 days. It's a little more stable than Bitcoin. But this is just another cryptocurrency that you can trade in. And so if you type ETH price, you can see the Ethereum price. Okay. Now, what's interesting in Ethereum is if you look at the top left, you'll find that the time to mine a block is a lot faster. Okay, what this means is that an Ethereum block gets mined in a minute versus Bitcoin taking 5 minutes, right? So this is a much faster system. So let me just explain. Let me explain at this point what mining means. Every block has a bunch of transactions. And you can see the transactions, some sample transactions on the right. A transaction is nothing but, let's say, me giving Rajiv 1 Bitcoin, a half a Bitcoin, or 1 million of a Bitcoin. So transactions pile up into a block. A block is nothing but a bucket, a file folder, a list, whatever you may call it. There are nodes or computers around the world which are miners. A miner, the the concept is that you're mining for a reward, right? I mean, you're mining for gold or whatever, precious metal. So using that analogy, there are computer nodes that are essentially verifying the transactions in a block. And how do you verify it? You want to verify the fact that I'm not double spending. So for example, I'm not giving Rajiv and Mark the same cryptocurrency, right? Which I could easily do. So miners are verifying that the transactions are authentic and accurate. And secondly, what they're doing is they are solving a puzzle, a mathematical puzzle. And the person who solves that puzzle actually becomes the winner of a small award, which is in Bitcoin, a small percentage of Bitcoin. Okay, so that's called mined. And when you solve the puzzle, that miner becomes the winner of that little bounty. And this tells you how long it took to programmatically solve that puzzle. And then the block is approved. And then you go to the next block and fill that block with transactions. Okay, so that's the essence of how Bitcoin, Ethereum, and most of these systems work. Each of these blocks are processed by miners. The miners verify that the transactions are correct, and then they move on. Okay, so a lot of physical, we know a lot about physical currency and fiat currency, so I'll skip through this. It's a distributed, decentralized digital system released in 2008. Okay, and then what happens a lot of times is that I do the slide, but there's a few important things in the slide that I want to. When Satoshi created the system, he engineered it in such a way that the total Bitcoins could not exceed 21 million. And this is in 2009, right? So by now, as of yesterday, about 18.82 million Bitcoins are in circulation. And this is just to curb inflation, so that you can't create more than 21 million. As I mentioned, blocks are created every 10 minutes. Okay. And so what happens is the reward for the miner increases the number of Bitcoins. So what happens is each block nowadays adds 6.25 Bitcoins into circulation. So Bitcoins are increasing in number, but they cannot exceed more than 21 million. Okay, and I've listed these. These are the dates of the presentations I've done in the past, including Colin College, I believe in May 2018. And as you can see, the prices have gone wildly. What I want all of you to note is that when you make a transaction in Bitcoin, it takes about 5 or 10 minutes to process and verify the transaction was correct. Compare that to any credit card, which makes 170 transactions per day. So Bitcoin is not exactly a fast system. Okay, if you draw the analogy with a check, what it is that in the Bitcoin system, if we participate in it, we get what is called a public key. Okay, everybody, if I sign up for the system, I get a public key. Think of a public key as your address. Everybody knows what that address is, and anybody can send money to it. Okay, but if you want to access your address, what you need is a private key. And that private key allows you to send money from that address to somebody else. So let's say I want to send Rajiv 1 Bitcoin. What I'd have to do is I would have to go into my wallet, which is a Bitcoin wallet, use my private key to access my wallet, and send whatever Bitcoin I want to Rajiv's public key. Okay, and that's how money is sent between one public key to another public key. But you need your private key to access your account. Hence, it's really important to store and remember this private key in one way or the other. Okay, this private key is generated by you. It's a P2P network. Most of us, I think, know what this is. As you create transactions, they're broadcast to all the nodes. Okay, a node is a full-fledged system that manages all the transactions. So the miners are essentially collecting transactions into a block. Okay, and I'm not going to go too much into detail, but there's always been some challenges into Bitcoin. First of all, is it legit? And then am I double spending or am I not double spending? That has always been a question. One thing I want to explain is this thing of proof of work. Proof of work is the reason why Bitcoin essentially incurs so much of transaction memory and costs and electricity. What it is that every miner has to solve a mathematical puzzle in order to get the reward. And to do that puzzle, what they're doing is they're essentially creating hashes one after the other to solve the problem. And this hash rate or creating the hashes just leads to a lot of electricity consumption. Okay, so it's proof of work, proof to show that you've done the work to solve the problem. So to get away from this high reliance on energy, there's been a lot of movement to go into what is called a proof of stake. Proof of stake is that depending on how much stake or investment you have in the system, you get bigger rights to solve the problem. In other words, think of it as a exclusive club of miners, okay? But what that does is it restricts the pool of miners, but also increases the chances of solving the problem faster. There are issues of validation. These are some of the issues about authentication, integrity, availability, confidentiality, right? And I'll just go through this. Everybody knows the public key in the Bitcoin network. In other words, if I send Rajiv one Bitcoin, I may not know that. Everybody doesn't know who owns the public key, but they know that one Bitcoin went to that public key. Okay, there's some practical limitations on Bitcoin. Economics, please read through this. Essentially, what it is that the reason the Bitcoin system keeps on going is because the rewards are decreasing by half every X number of years. So every 4 years. So initially it was 50 Bitcoin reward. 2013 it was 25. 2016 it was 12.5, and 2020 so the rewards keep decreasing. And so the Bitcoin system will stop giving rewards in 2140. So there's a while before it goes. I'm kind of running out of time, so I'll skip through some of these things quickly. There are mining pools that make most of the money these days. There's pseudo-anonymity. There is not, you really don't know who owns the Bitcoins, but you have an idea of that how much is in a wallet. There are many alternative coins that have been spawned Bitcoins, and I just want to mention them in here. They're called altcoins. Altcoins are faster, right? They fix some of the issues that happen in Bitcoins. And this is just a list of all the cryptocurrencies that have been created after Bitcoin and Ethereum. And there's quite a few of them. Not to mention stablecoin is a type of currency stablecoins came out a few years ago where the price is stable because of an asset. Okay, and the asset could be all these things. These are popular stablecoins. I'll go through this just in 30 seconds. This is actually a true transaction. So what happens is Joe gives Alice's address 0.1 BTC. Alice gets the 0.1 BTC, sends it to Bob. Of 0.1, she gives 0.015 to Bob. So she has what is called change. A change left, 0.845, of which there's a transaction fee of 0.005. So if you see the second transaction, you will see quite a bit of information. And then what happens is Bob takes 0.15 BTC that he's got and sends it to Gopesh and has some change, okay? And this is the block for Alice in the real chain. So I've given a couple of labs. Mark, I don't think we have the time to go through this. If you like, you can run these labs at your leisure. Okay, I'll run the lab. I mean, I think most faculty members like to do some hands-on stuff. Okay, so what I'm going to do is I'm going to share my screen one more time. All of you can actually do the same thing with the lab.
There was one question. The question was, At what level does money change hands? I guess that's the question.
Money can change hands at any level. You can have anybody can create a wallet and exchange money with anybody else. This is a completely open distributed system. So this is something called Remix. And so what I'm going to do is I'm going to give you, this is the beginner lab if you have it open. What I'd like everybody to do, and this won't take more than 5 minutes, I promise. Open something called the Remix IDE. Okay, I've put the thing in chat. Okay, and then so what you want to do is you want to run this code, hello world.solve. How does the value fluctuate? It is all about people speculating on the value. That's all it is. Okay, so in Remix, what you want to do is you want to open the file. And the best way I can put it is like this, where you open a file and you have this. Again, if you can't do this in this workshop, it's fine. You open the file, right? And then what you want to do is you want to open the file. Right. So that's the code. I'm assuming everybody can see it. What this code is doing is essentially displaying hello world and as a function and killing the code as another function. So function die. Okay. So what you want to do is you want to compile hello world. You click compile. You compile it in bytecode, and we can check it later, but I'm not going to do this right now. Then what you do is you deploy that code somewhere. Remember, this is the blockchain. So you're deploying this code on the blockchain. So you deploy it. Okay, and all these instructions are in the lab. Once you've deployed the code somewhere, you have the code, you've deployed what is called a contract on the blockchain. Okay, and this contract is based on this code. So it has two functions right there, print hello, which is this, and die, which is another function, which is that. So if you click on print hello, you'll get the output, hello world. Okay, so if you this is a very trivial code, take it for what it is. And then if you click on die, what will happen is this function will kind of kill itself. And if you do print hello, it doesn't work again. That's about all this does. How did you register this in blockchain? When you this is not a real blockchain. This is just a pseudo blockchain written in JavaScript. If you want to do it for real, what you can do is you have to go into this thing called injected Web3 and things like that. So I really didn't deploy this in blockchain. This is just a mock blockchain, but the concept is the same. In the intermediate lab, you will actually deploy this to the Kovan test blockchain. I mean, I really don't have time for this, but I'd like faculty members to go through the intermediate lab. And you will deploy code to a test blockchain and you can check it out.
There were two other questions about the logistics. So the bank account has to be registered for deposit of the money, of the crypto money? That was one question.
Yes. So the latest thing is that if you sign up for a wallet in Coinbase and things like that, you have to register yourself first so that you're a legitimate user. And for example, many states like Hawaii does not allow me to own a wallet account. This is to just curb fictitious accounts and fictitious money.
Also a question, how does the value fluctuate? Is it buyer interest or actual assets?
So that, I wish I knew the real reason. I think it is nothing more than speculation in the prices. It's no different than buying some of the stocks that we've seen in the past few months that are wildly going up and down. It's all about speculation and parking your money in some place where you may consider safe or speculative. There's no intrinsic reason. There's no intrinsic value of a Bitcoin, right? Yeah. Yes, exactly. So Coinbase, Rajiv, is the most popular place for you to buy Bitcoin. Now, anybody in Texas can buy a Bitcoin today. I can't in Hawaii. And so there are regulations based on a state's policies about exchanges. It is about trust. The system, you can trust the system, but you can't trust the speculation or the speculators. There are different things. the labs have a lot more detail. If you have any questions, you can send me email, but I appreciate your time and interest in this topic.
So thank you for your time. Thank you for joining us. Thank you to Debasis for his time as well.
Yeah, thank you. It was
This
fun.
is great. Very cool.